This is a tutorial on how to solve a combustion analysis question. Here, citric acid is composed of carbon, hydrogen, and oxygen. A carbon-hydrogen combustion analysis of 0.5438 grams of citric acid produced 1.039 grams of carbon dioxide and 0.6369 grams of water. Its molar mass was found to be 192.124 grams per mole. What is the molecular formula of citric acid? Here we've written a chemical formula. Citric acid plus oxygen forms carbon dioxide and water. Here we've written the mass here. And in order to find the mass of carbon in citric acid, we must first perform a technique called percent composition. Here, percent composition of carbon is equal to 12.011 grams over 44.0098 grams times 100% is equal to 27.29%. Next, to find the mass of carbon in carbon dioxide, we must convert the percentage here into a decimal, which is 0.2729 times 1.039 grams. This equals to 0.2835 grams. Next, we do the same thing and find the percent composition of hydrogen. 2 times 1.00794 grams over 18.01528 grams times 100% is equal to 11.19%. The reason why we multiply by 2 is because there's 2 hydrogen atoms in one water molecule. Once you find the percentage here, we must find the mass of hydrogen in water. First, you convert the percentage into a decimal, so 0.1119 times the mass of water, which is 0.6369 grams, and this equals to 0.0712 grams. To find the mass of oxygen, we must get the total of the citric acid and subtract that by the masses of carbon and hydrogen. So 0.5438 grams minus 0.2835 grams minus 0.0712 grams is equal to 0.1891 grams of oxygen. Once you find the masses of these elements, we must convert these into moles. So 0.2835 grams of carbon times 1 mole of carbon, 1 mole of carbon over 12.011 grams of carbon. This equals to 0.0236 moles of carbon. We do the same thing for hydrogen, so 0.0712 grams of hydrogen times 1 mole of hydrogen over 1.00794 grams of hydrogen is equal to 0.0706 moles of hydrogen. Next, we also do the same thing for oxygen, so 0.1891 grams times 1 mole of oxygen divided by 15.9994 grams of oxygen. This equals to 0.0118 moles of oxygen. With these moles, we must identify the lowest mole, which is oxygen, as it's 0.0118 mole. So we divide these moles by the lowest mole, and here we get carbon is 2, hydrogen about 6, and oxygen, which is 1. These ratios gives us the answer of the empirical formula, which is C2H6O. But we're not looking for the empirical formula. We're looking for the molecular formula. So we first must find the molar mass, which is equal to 46.06904 grams per mole. This is by adding up the masses of each of the elements here. So 2 times 12.011 plus 1.00794 times 6 plus 15.9994. Once you find the molar mass of the C2H6O, we must do the ratio, which is equal to the molecular mass of citric acid, which we got from the beginning. No, not the molecular mass, the molar mass, which is 192.124 grams per mole, and divide that by the molar mass that we've written before, which is 46.06904 grams per mole, and this equals to 4. This number, we use this to multiply the ratio we have here to get the molecular formula. So 4 times 2 is 8, 4 times 6 is 24, and 4 times 1 is 4. So the molecular formula is C8H24O4.